If you caught the November episode of the Design Build Delivers podcast, brought to you by US CAD and Archon's company, you heard all about the 2024 DBIA Project Team Award winners and how Design Build played a key role in their success. But now we're shifting gears a little. This bonus episode is all about the projects themselves, what they do, why they matter, and how they're shaping the future. And let's be honest, this also gives us another chance to revisit some fascinating stories like the time a boat capsized in Antarctica. As Brandon Shaggy Nahusen so perfectly put it,
the boat capsizing just sucked.
Yes, it did. And if you want to hear that full story, go check out our November 2024 episode. For now, I am your host, Erin Looney, and in this Design Build Delivers podcast bonus episode, we are taking another look at 3 of 2024's biggest Project Team Award winners. The University of Arizona's Applied Research Building was the Project of the Year. The Holt Watters Field Camp was the winner of the prestigious Chairs Award, and the National Renewable Energy Laboratory's Research and Innovation Laboratory was a 4-time award winner in 2024. In the last episode, we spent time talking about how Design Build brought these projects to life, but this time we're going to focus less on process and more on what makes these projects so freaking cool, and they really are. And if you want to learn more about DBIA's Project Team Awards or even submit a project for 2025, stick around. We've got details on that at the end of the episode. Now let's get started.
What I understand, it's very Instagrammable.
We had photos and the eBay listing for it.
They literally bought it themselves and said, hey, can you put this in the building?
What in the world could they be talking about? The University of Arizona's Applied Research Building is a powerhouse of innovation, bringing together cutting-edge research, high-tech facilities, and bold design choices. From advanced space science to groundbreaking research tools, this project is full of surprises, including a few twists the team and definitely I never saw coming. So let's hear from the team behind this award-winning project, including Andrew Gillett, the pre-construction director at McCarthy Building Companies, Dana Sylvester, construction phase project manager from the University of Arizona, Katie Stackler from Smith Group, who helped lead the design portion, and Brian Brandis, director of planning and design at the University of Arizona. What were some of your favorite aspects of working on this project? Was there anything that stood out or felt different compared to other design build projects or other university projects that you've worked on in the past?
The building is centered around the thermal vacuum chamber. Listening to the main researcher from the university who was working diligently to get that component of the building dialed in and explaining to the design build team what was the purpose of that. We designed the building around it. If it had not been a design build methodology, I don't know that we would have come to that same conclusion, and nor would it have gone as seamlessly as it did.
That TV chamber, so little was known about it when the researchers bought it. They literally bought it themselves and said, hey, can you put this in the building? As it turns out, we couldn't put it into the building. We had to build the building around it. So after we placed the slabs for the first floor, we brought the TV chamber in, we set it in place, and then we protected it, and then we poured the next 3 decks around it. And so it sat there in the middle of the building as we constructed it. While we were doing that, the researchers worked on a design to make it operative again because it hadn't operated in 20 years. So it was really collaborative, really fun, just a unique project that I don't think will ever be replicated.
You're talking about these unique characteristics and things you're never going to see again, and this project utilized progressive design build. Is there a connection between the unique and, frankly, kind of bizarre story you just told about the chamber and using PDB in terms of its ability to benefit and make sure that you delivered this project the way you wanted to?
The one researcher requested this anechoic chamber that's 30 feet by 30 feet by 30 feet. So it's a massive, big cube, kind of looks scary when you look inside of it because it's all these cones and everything, but you can't hear echoes inside of it, and they test all sorts of equipment in it. When we did our ribbon cutting and walking through the building, the researcher said, well, I just wanted to ask for the biggest anechoic chamber I could get, and he didn't even know if he could get it. We were building and designing something that we didn't know if we could do it, and we found the right consultants, the right engineers to help with design assist as well as part of that process to make that happen.
That's why progressive design build was so important for this project, to not have a preconceived design at all, to just have an open book, an open mind, and to be able to create from that point made it a huge success.
Yeah, the progressive design build delivery allowed us on these elements that were totally unknown. The thermal vacuum chamber, the anechoic chamber, which is also my favorite room in the building.
It's beautiful. It's not scary.
It's cool looking, yes.
Depends on whether you're inside it or outside it.
And from what I understand, it's very Instagrammable. From what I understand.
And it is unique. It's one of a kind. It's, as far as we know, I think it's the biggest radio frequency anechoic chamber on a university campus. And when the researchers asked about it, there was no precedent to be able to price it from. So we just recognized that it was a risk that we had to work on as a team to mitigate. We placed an allowance on it, and then we dove into the research to figure out how we could do it and what it could cost. We found the right consultants to help us develop it. We never had to value engineer ever on the project.
The university did allocate more money for this project, realizing the value that it was going to bring not only to the university, but also to the community of Tucson and the surrounding areas. There were quite a few different departments and so forth that were coming together. And in my previous experiences, that could cause some competition. And it was really a pleasure to work with all of the scientists because they also understood the larger mission. It wasn't just the design build team that was collaborative. It was the university and the users really understanding that larger mission to bring all of these different programs and aspects together and how that was going to allow them to be able to advance their research much quicker.
This project also featured VDC technologies like augmented reality. How did these tools enhance the project's efficiency and accuracy, possibly address some of the issues we've already talked about, and what impact did that have on meeting the university's research goals and the mission?
As Andrew mentioned, we did not have the thermal vacuum chamber. We had photos and the eBay listing for it. That was one thing.
They got it on eBay?
They bought it on eBay.
In New Jersey.
Okay. Now I have a whole second interview I want to do now.
Or $650,000.
Oh my gosh.
Just gloss over that.
And
The
eBay
whole building
listing.
is built around one piece of equipment that they bought on eBay.
Some scientist said, I got to order that. That's crazy.
That's exactly what happened.
Dominguez that's behind it, he actually built it. You would see his mechanical drawings. He'd had hand drawings. He had also CAD drawings, but every little component had a certain place where he had tagged every piece to make it operate correctly. They took all the guts out, the shrouds, refinished everything, and then he was the brilliant mind behind it to get it operational for their needs.
And he worked hand in hand with the design build team directly. He's been in meetings for the last
He really
3
became
years.
like a consultant.
Yeah, he was directly involved still to this day.
So we can move back from Rubin and eBay. But that was a tangent that needed to be pursued.
But that's part of it because he was doing drawings that eventually got integrated into the BIM model.
And then immediately south of our building is Speedway, which is a main thoroughfare through the university. And there's an underpass that goes through there. And I know people don't think it rains a lot in Arizona, but when it does rain, it absolutely floods. Working all that out virtually ahead of time and seeing how we could make it safer, more pedestrian friendly, accessible. There was quite a few components that we had to model obviously ahead of time and make sure that they worked out as we were working on the construction.
So we didn't have any exposed conduit within the building because we do have a lot of exposed slabs throughout the building, kind of being industrial looking. You don't have conduit running on these nice exposed decks everywhere. That's a huge undertaking in itself to show the bones of the building.
But we do have some exposed. When it was laid out, it's beautiful. The conduit is a gorgeous thing to see. So I know a lot of the electrical engineers, and they would appreciate this because it's something that we often want to hide.
I know we've been talking about a vacuum chamber, but this project on the whole doesn't exist in a vacuum. Terrible segue. It is on the planet Earth, despite the space references, and it is part of a community. So sustainability and community engagement were key components. What steps did you all take to prioritize these aspects, especially with all this other stuff we've been talking about?
University is a big proponent of sustainability. So we require all our projects to be a minimum of LEED Silver. We have Watt Stopper. We've got lighting controls. We've got building controls, automation for HVAC. We're also big on water harvesting. So the landscape of this building is also incredibly beautiful and well thought out with the plants that were selected. And then there are swales to capture water during rain events to help it percolate through the ground and move slowly. It's almost like a river basin, And so this helped a lot for the campus, surrounding buildings and adjacencies. We had hundreds and hundreds and hundreds of people involved on this project. So from all the trade partners involved, the contractors, the suppliers, equipment, materials, is huge for Tucson community.
Another aspect of the sustainability was all those folds and fins on the facade. We did energy modeling and dialed in exactly the angles of those fins to make sure that they were in fact shading the windows behind them.
As part of the lead requirements, we also brought on the commissioning agent during the design process to help us with design of the mechanical systems and functionality. Where this building sat before, it was a horrible pedestrian bicycle pathway with ramps for universal accessibility, and it wasn't part of the project originally. And again, part of the design build process, we were able to incorporate a better pathway, and through very good design, we made everything universally accessible across the site. We made the request at the beginning of the project. I think you broke ground in like May, and we said we had to have this $2 million worth of site done by the start of school in August, and they pulled it off.
It was a great foresight by the university to recognize the impact that improving the pedestrian pathway and the bicycle pathway would have on sustainability for the community. Because now people don't have to drive to campus. They had a safe way to cross Speedway and to get to their campus in a sustainable way, made it more bikeable, more walkable.
Smith Group, we pushed back on them a little bit too, to constrain the site a little bit so that we'd have room for other future building sites around it as well. Originally, the building was a little bigger, so we asked them to tighten it up a little bit.
We called that the slice and dice.
The slice and dice.
We're going to leave Earth now. Inspired by space exploration, the building's design balances functionality with this open, collaborative environment. Walk us through some of the unique design elements and how those support the university's mission for innovation and research.
So they build and develop high-altitude balloons that they send up into high-altitude areas. And this is kind of the area of research between sending things into space, not quite satellites, because it's cheaper. This was another major component that this whole building is built around. It's a 80 by 80 by 40 foot space within the building. So that's tied directly to the connection to the thermal vacuum chamber, the anechoic chamber, and the mission control center. So they can actually run space missions and CubeSats out of this mission control from the University of Arizona. A lot of these programs and departments were across campus, and the original thought was to bring these scientists together under one roof so that they could collaborate and cross-pollinate and kind of have that casual interaction. So you walk through the second floor corridor from their office to lab, and there's probably a 60-foot corridor of whiteboards, and they're scribbling stuff that I don't think any of us know what it means, but they're doing all that. And there's the imaging technology lab that builds sensors for cameras and telescopes and satellites. Some of that was developed that's on the Webb telescope now, and OSIRIS-REx that went to the asteroid. University of Arizona has been involved with every single NASA mission since its inception.
We did know that this was going to be a world-class, once-in-a-lifetime facility, so we literally designed in a tour route, knowing that they're going to be coming to the building, and we do want as much of the science on display as we can have. But again, we need to have that security. So we have very large windows, for instance, that look into the high bay area, but there's also screens that can be put down. So if it is a mission critical component that's going in there, then you would not be able to see that on the tour route.
I thought that was a very interesting dynamic of designing the tour route into this, because part of any university is getting the funding. So they mentioned right off the bat, we're going to have 3-letter departments coming through this building. We need funding from DOD and the government and all those type of places. So how do you design a building that is secure and also open at the same time?
And I imagine for recruiting, if you want to come there to study, you want to see proof that you're going to get what you're committing to. It's been really great talking to you. I'm thinking of a career change. I'm so fascinated now. I want to go to the university and study space exploration.
And I love sci-fi movies, but this takes it to a whole new realm. Now I want to understand, actually what they do.
Do you say, that doesn't seem real now when you watch
this? Yes, absolutely. Sometimes it's too real, yeah.
Are you interested in sustainable design and construction practices but concerned about profitability? USCAD, an Archon's company, helps forward-thinking ENR top-ranked AEC firms in mitigating risk and driving profit through digitalization using Autodesk AEC technology. To learn more, contact uscad.com/DBIA for a free 30-minute consultation. That's uscad.com/DBIA. From the extreme environment of space to one of the most extreme environments on Earth, next up, we are heading to Antarctica. Holt Watters Field Camp isn't just a research outpost, it's a testament to sustainability, resilience, and as I hinted earlier, the kind of problem solving that comes with working in some of the harshest conditions imaginable. This project took home the Chairs Award for its environmental, social, and economic impact, and if you think working in Antarctica is tough, yeah, you're right.
The wind is your constant companion.
You do not want to be figuring anything out in Antarctica.
That mindset led to a groundbreaking prefabrication approach, innovative energy solutions, and a structure designed to leave absolutely no trace. Here's more from my interview with Brandon Shaggy Nahusen, the Director of Design and Construction at Bespoke Project Solutions, and Ellie Mango, or simply Mango, as I learned in November, nicknames are mandatory in the South Pole, the Field Operations Director at Bespoke.
The Holt Watters Field Camp stands out for more than just the design build aspects, which of course, we like, but beyond that, it's cutting edge in a lot of different ways. This is an extreme environment. So could you talk about the origin and the goals of the project and sort of some of the specific design and construction challenges that were faced in this location?
People are not in Antarctica to fool around, especially the science community. We're not down there to take pictures. We're not down there to leave any kind of a mess. We tread very, very lightly. So this wasn't just about a green building or a building in Antarctica. We're really trying to set a precedent for that environmental, social, and economic responsibility. So environmentally, it's a zero-emission facility. Socially, it involves diverse collaborators and brought a lot of folks into the field to build those buildings while really paying attention to any sort of environmental impact that we'd have. And then economically, it really proved that design build can deliver a high-value solution under extreme constraints for a relatively smart budget. The government got what they needed out of an economic facility, really economical facility. The students learned probably more about Antarctica than they ever wanted to know, and Bespoke could bring all that together and build those facilities for them, safe, comfortable, environmentally friendly, and not taking a square inch more than what they had before.
I think I want to specifically highlight just what a different ballgame the Antarctic Peninsula is compared to other places on the continent that Bespoke has worked before. We didn't have, any equipment whatsoever. We had an ATV. We were landing on a beach. We were moving materials up to this job site. We were moving them across the Cape to the second job site. The wind is your constant companion. It is just one of the most brutal places that I've ever worked on the continent, and that deserves to be mentioned because it is no small feat to do even the most minute, simple task there. And it takes a lot of hard work, teamwork, communication, specifically once you get to the field with your plan in place.
The snow at least kind of facilitates you not leaving a mess, right? You don't leave tire tracks, you don't leave footprints, you don't leave anything. So as that snow goes away, while it's tough to shovel, and we call it the Cape Sheriff CrossFit program with all the snow that we shoveled last year, but really, once the snow goes away, now you really got to start thinking about how you're not going to leave any marks on the face of that place. So I tell the team all the time, if we're always going to be past plan A, B, C, if we're not to double Y, double Z, we're not doing our job.
What does removing all traces look like?
So remember that we land at a beach. The main camp is about a quarter mile away. That's a pretty established, I don't want to call it road, but that's a pretty established 2-track. The other camp that we built was about a mile and a half away from the beach. So that's a penguin blind. That is meant to be in the middle of a penguin rookery. It's an observation post for the scientists to do their work, but it's also kind of a lifeboat just in case, and God forbid, fire is our worst enemy there. So if the main camp ever burned down, they would have an alternative solution there to stay until the cavalry can come and save them. We had a mile and a half to get out to that. Some of it is really picking our path on how it's going to go. We know what the environment, we know what the weather is going to do eventually, and it's going to kind of remove any sort of tire tracks, but you just stay in that exact same in, exact same out, and no fooling around out there. You just make as least of amount of any sort of footprint that you can.
Demo too, picking up every nail, every speck of paint, every piece of molded out plywood that you're taking down and packaging it up so it can go off continent. Antarctica is pack in, pack out with garbage, the whole continent.
So let's talk prefabrication and modularization, which were central to this build. What advantages did these methods provide in balancing efficiency with durability?
Prefabrication for us wasn't just a preference, it was an absolute necessity. We have such a small window of construction, so building it here in Denver allowed us to really control the quality, reduce the waste, and test any of the systems before we ship them thousands of miles, right? It also gives us flexibility. We joke it's like Legos for grown-ups and parkas with the dexterity of penguins. You do not want to be figuring anything out in Antarctica. You want it already figured out, and you just want to be putting it back together. And again, like we were talking about on the environmental impact, you don't want any waste. We don't release so much as sawdust into the atmosphere there. It's already built. It's already done. Another part of that is the way we had to flat pack these. So we put the buildings together, again, with the students. We allowed the clients, NOAA, to come see it, touch it, feel it, imagine what it's going to be like, request any last-minute changes, which there were very few because we had talked so much and collaborated so much throughout the design process. There are no Home Depots in Antarctica whatsoever, so everything has to be thought out. I mean, you really have to have everything, every single thing thought out. So to prefab it here, we knew we had all the parts, we knew we had all the pieces. Now it's just a matter of shipping them thousands of miles and across the Drake Passage and get them there. If you don't have everything thought out, you're sunk.
Now, moving on to something we've hit on in some of your other answers is the importance of community engagement. That was a huge part of a remote project like this, the success of it, and a big part of how you nabbed the Chairs Award. And you've talked a little about the work in Denver. You've talked about working with the students. How did showcasing the prefabricated structures in Denver and involving those students enhance the project?
It was a game changer for us. It allowed us to really not only share the project's story, but the scientist's story. There's very few people that even know that this place exists, let alone that we're there and we're doing work. So it allowed us to show off the students' work. It allowed us to show off our design work. We could do that for the administration of CU. We could do that for any sort of donors. The scientists, obviously, they could very much see, like, this is my bunk. This is where I'm going to cook whatever it is that they're going to make for dinner. It's one thing to say, we built a building in Antarctica. Your mind can go anywhere, but this actually shows you the building. And you can kind of envision yourself there. And I think that awareness will probably open your mind up to really think through, what are we doing there? What is it like? You know, it can answer some pretty important questions. The other part that was great for us is Bespoke has a lot of experience building in Antarctica and polar regions, but it allows a 23-year-old grad student to be like, why are you doing it this way? And then that gives us an opportunity to be like, are we just being idiots in the last 25 years of Antarctic design, or is there really a reason for this? Usually the answer is yes, but there's been a couple of things like, yeah, I don't know why we do that this way. So it opens up a new way of looking at how we approach the facilities, how we approach the architecture, how we site the buildings, how we build the buildings, and then eventually the disposition of those buildings to be taken off the continent. So again, we don't leave any marks whatsoever.
So the theme in our conversation thus far has really been that this was designed for minimal environmental impact, period. But let's talk about another aspect that we haven't really hit on yet, relying entirely on solar and wind energies.
Again, that really wasn't an option either. I mean, shipping water there is not going to be a thing. To use the least amount of fuel possible, we have generators, but you don't want to use those. You don't want to smell them. You don't want to hear them. Any of that. So really we started back in the design. You'll notice that on a couple of buildings, they have that twisted gable, the way the roof line is. That was very intentional, not just from an architectural that looks cool standpoint, but that was really thought out to be able to capture as much meltwater as we could, because that's what they use for drinking water. They capture that and hold that and then run it through filters, and that is your water. The solar just completely made sense. Cape Shiref in particular can be a bit tempestuous, I would call it, with the weather. It can be pretty cloudy, it can rain, it can snow. 31 to 33 degrees where it's just snowing cats and dogs, and then it turns into rain, and then it goes back to snow, and then it turns into rain. The solar was just absolutely made sense. To have the batteries to store that energy, it was the only thing that made sense, to just not have to run generators.
This goes back to the theme that I was saying from the very beginning. In Antarctica, you got to work with nature, not against it. We're given wind at this location, use it. We're given water, let's collect it. The austral summer has sunlight 24/7 for months. Let's use that. Let's work smarter and not against the forces that are there.
And try not to get space madness.
Yes.
So we've talked also not just about the environmental impact, but about collaboration. And collaboration on this project happened across so many regions and so many sectors. Obviously, that can lead to some complication with cohesion and teamwork. So how did you maintain cohesive teamwork and effective communication with people geographically dispersed?
At the risk of sounding corny on this answer, the love for this building from every single person involved made it not hard. We have people in Australia, we have people in Chile, we have folks here in different time zones. It really didn't matter. When we had something that we needed to figure out, or we had answers that we needed, nobody really cares about sleep at that point. We just set it up in a time that works, and then we have really clear deliverables. This is what we need to accomplish. Our collaboration software really helped. Everybody could see exactly what we were talking about. We didn't have to do sketches on the back of a napkin or anything. We could really build these models. They could see it and rev it. When you love something this much, you're going to make time. You're going to figure out how to make it work.
Given the nature of the location, it just forced really good pre-planning, all the things Shaggy just talked about, because once you're in the field, I just want to say that it is the only way you're communicating is with a satellite phone or messenger or carrier pigeon. I'm just kidding, but the
Would that
once
be carrier
a day,
penguin or carrier penguin?
yeah. Honey.
Yeah.
The carrier penguins are already working hard, building their nests. We can't use them. So the internet is on for an hour a day to send and receive emails. I just want to highlight the complexity and difficulties of sending messages in and out in any capacity from Cape Shiref, and how important it is that you've pre-planned with everyone before you get to the field.
Internet there is dial-up in the early 90s, maybe, and your mom keeps picking up the telephone, so it cuts. I mean, it is an absolute. You don't want to be talking there. You want to have all the conversations you needed to have way before then.
And that is what makes working there so awesome, honestly. That's what attracts me to it. That's why Bespoke loves it. It's a really fun challenge and so unique, especially in the modern era.
Being able to communicate contemporaneously it's ubiquitous. And to think, how do you strategize your communication? There are people who probably couldn't do that. Question for both of you. Were either of you on the boats that capsized?
No,
Okay.
I was on the main boat, so we just heard about everything over radio. We have satellite texting, so you could use your phone, but it's like old Twitter where you get 127 characters, and that's it. So I sent a text back to the office, and I was like, terrible day, the boat capsized, everybody's going to be fine. And then I put my phone down, and as you can imagine, there's a lot going on the vessel, and we're talking back and forth with shore party, and I didn't realize that when I went back, I didn't specify which boat had capsized, so the whole office team is like, what are you talking about?
Oh, no.
And then I came back 45 minutes later, and I was like, oh yeah, it's no big deal. I mean, it was a big deal, but everything's safe, everything's fine. She's like, you're an idiot. I thought the whole boat, I didn't know what. So, my bad. Should be a little more clear in my comms from now on.
Well, you only got 160 characters to do it, so you were probably as clear as you could have been.
Exactly.
One of my greatest fears in the multiverse is the ocean. I purposely watch North Sea videos to scare myself. And now I'm going to go watch Drake Passage videos and I don't know, maybe never sleep again. I commend you guys for keeping it together.
If designing for Antarctica meant planning for extreme cold, designing for the future of energy meant planning for the extreme unknown. And that is exactly what the REL project team had to do.
We envisioned to say, what can we do to say that in the future, I can at the least cost add more lab space to this building?
The National Renewable Energy Laboratory's Research and Innovation Laboratory, thankfully REL for short, isn't just another research facility. NREL's mission is about energy efficiency, renewable energies, sustainability, and clean energy research, and the REL project is a vital piece of meeting that mission. It's built to evolve, to support next-generation clean energy research, and to drive real change. But the team behind it had to navigate some unexpected challenges along the way. Let's hear from Brett Cummick, Program Director for Project Management and Construction at NREL, about how the team made this ambitious project a reality.
The submission emphasizes flexible interdisciplinary research space for energy innovation. So talk about the origins of this project and the vision behind creating this adaptive collaborative facility.
We've been looking and seeing that what happens at NREL happens a lot of other facilities as well, is that over time, research missions change, research evolves, and some of the labs that you had built for certain purposes aren't being used as effectively as they could or should. And then you're faced with, how do I solve the problem of having less effective use of space? And to go in and remodel these spaces is a very, very expensive and lengthy process. A typical lab space for the research is usually about 1,000 square foot space. We knew we could fit somewhere around 5,000 to 6,000 square feet of research laboratory space. So the initial vision, we can get 5 new research laboratories. Our director said, no, I want to do a new model within DOE where we only build 2 labs, much larger labs, and make them so they can be easily, efficiently, and effectively changed to meet evolving research, and they can also be shared by different groups. So it was all about breaking the paradigm of creating spaces that would become inefficient over time and very costly to redo. We wanted to create spaces that could then now be what we call roll out and roll back in to serve a new research purpose very quickly. So that was the focus of what we've done, looking towards the future and in creating that space that'll be much more effective.
But also, I'm assuming, still be specialized in ways, just more easily specialized.
Exactly. Specialized at a lot less cost and in a lot less time. So we incorporated a whole lot of strategies to do that.
Some of these approaches to ensure that flexibility involved innovative solutions like modular mechanical systems, a microgrid connection. What inspired those choices, and how did design build support the success of those features?
We received the money to begin this project a month and a half before COVID occurred. And we had this challenge, so not only to do this unique, innovative, flexible lab, but we had a challenge and were requested by DOE to say we also want to show how quickly we can create this project. And our typical delivery schedule is actually very aggressive compared to other models. We looked at putting together various strategies that will not only let us get it done quickly, deal with the challenge of a global pandemic, but also meet our mission for who and what we are at NREL. We have a group called our Intelligent Campus who had envisioned microgridding part of our campus. A lot of that grid could be fed by solar, hydrogen fuel cells, and other clean energy power sources to supplant some of the needs within the building. And our initial target was to be able to make a connection where we could hook up a hydrogen fuel cell and remove the need for our current diesel backup power. As we did this and working with our design team, we realized it required a different thought process, which says you can't just go build your standard electrical type connections. You need to have this in mind when you start at it. Right at the table after awarding the contract, we sat down with the design builder and said, here's all the ambitious goals that we want to incorporate within our budget. And let's talk about what we can do and how we can facilitate these solutions. And the microgrid was part of them. Some of the other strategies is being in the pandemic. I think a lot of owners have seen that there's a lot of challenges, especially on federal work sites with labor and having labor shortages. Our major subcontract partners working with their design builder came up with some unique solutions. One of them from the mechanical was to say, up here in the penthouse, a lot of the mechanical equipment we could build in our shop rather than our normal construction on site, and we can do it at better quality, better efficiency. We can build them on skids, bring them out, set them on these skids already prefabricated, and simply connect these pieces together. That allowed them to be able to have their workforces in-house rather than out on site. We had 2 air handling units that we got called up 2 months before they were supposed to arrive on site, and they were closely timed so we could finish our building. And the vendor said, we're sorry, but we can't get metal in this condition through the supply chain, and we're going to be 6 months late. We said, we can't stop our building. We need to finish it. We're scheduled to dry it in and complete a lot of construction here in a month. So having a good, close partnership with our design build team, we came up with a collaborative solution of taking our structure and building some large hatches into the roof so we could close in the building, but when those units arrived on site, we could open them up, drop them in, finish the building, thereby reducing what would have been a significant delay.
It's really interesting listening to you talk about the being able to put those units in there after everything was done, because if they ever need replaced, you can just open it back up and take them out.
Very valid. You went a very good direction. I can tell you there's buildings that have had to come in and cut holes in the roof to get out, pull crane units out of the roof to be able to crane in replacements. So this one we realized was not only a great solution to a problem that came up through a supply chain delay, but it creates a long-term solution for down the road when those units pieces of them have to be replaced. We got a way to get them out and get them in.
Can we talk a little more about the future research flexibility specifically? You mentioned that some of these labs, they stay pretty basic with some roll-in, roll-out specializations. You were projecting the future a little when you were doing this. So what were you thinking of? What areas did you envision moving in and out throughout the next few years?
I'll tell you about that, but I'll tell you about another strategy that we built in early with our design build team. We knew we had a budget limitation, and we could only get a certain amount of lab square feet, but we needed more. We envisioned to say, what can we do to say that in the future, I can, at the least cost, add more lab space to this building? We realized that we could plan a future expansion of the building, and we could minimize it, that if we looked in advance of how we planned this building, and we upgraded certain elements. For example, we only needed 3 restrooms for this facility. We realized that if we added 1 more, when we build an expansion, we wouldn't need another restroom. We realized that if we design the corridors and the common spaces and the shared areas and our break rooms and all of these things correctly, they would support an expansion, almost doubling our lab space without having to increase our facility. We upgraded key components of our infrastructure inside the building so that now when we want to build this future expansion, it's only building the addition. We didn't know it at the time, but we were able to get funding for that expansion shortly after we completed REL. So being prepared is paying huge dividends for us to very quickly get that additional wet chemistry laboratory space that we so badly need.
And do you think that's why you were able to get to the funding so soon?
We think it's always a help. Anytime government funds are being used, the more effectively and the more value you can deliver to the government and the taxpayers, that helps when you are getting funding. And on talking about the flexibility of the labs, we also extended that to looking and say, if I want to reconfigure these labs, there's certain things we can do in the way we design a lab. We built in a crawl space so we can reconfigure underneath the lab. We sized all the infrastructure and distribution systems within the lab to make it very easy to pull equipment out and in and hook it up very quickly. That's an important thing for owners to think about, is not just your current need, but the future. A little pre-planning will save you a whole lot of money. As far as the current uses, we built one lab that is 3,600 square feet, we call our large lab. Another lab that's 1,800 square feet, we call our small lab. And now within that has 3 researches. So we're sharing laboratory space between different research groups. So we currently have one that is focused on energy-type materials. Our microbial energetics group is initially moving in the large lab. Our smaller lab is being shared by 2 groups. One that is doing advanced battery research and one that is doing photovoltaic research on alternative materials to silicon photovoltaics. So while they're needed, they will be there, but the NREL leadership has said, now you don't own this space, this is shared space. Should your research change or we have emerging, we will move groups around to continually make sure that we're effectively using the space and maximizing the efficiency.
I do not have any idea what microbial energetics is, but it seems that if there's an opportunity to collaborate in the lab, it's probably a lot easier when you're sharing the space, but you're not in each other's actual space. It's a recurring theme throughout this project that creating collaborative environments are a big deal. That's a big focus here with, as we've talked about, the lab space, but also open interaction areas. How did these design elements enhance that research environment?
One of the important things for research are that I think over time people have learned is to get creativity and innovation requires collaboration on researchers. And sometimes some of the best ways for that to happen are for what we call these kind of intentional collisions, opportunities for researchers to be together and stimulate conversation and get to know each other and share their research. So as part of this, we didn't create any individual offices within the REL building. It is all a common area, touchdown space, heavily focused on the lab areas where they can sit down and do some of their work before going back to their home office at another building. And they will then be exposed to other researchers, start up a conversation, discuss research, and often when they get started down that road, they come up with new ideas. We wanted it to be attractive focal areas. So we look at an internal collaboration zone and an external collaboration zone that are very attractive.
In my mind is a bunch of mad scientists colluding.
Yeah, there's a lot of research that when people do get that chance to collaborate and think, they come up with a new idea. We were supported by DOE to say, let's put money into these collaboration zones to stimulate that type of activity.
3 projects, 3 incredible stories, and 3 more reasons why Design Build continues to push boundaries across sectors and industries. If you were inspired by these winners, and you should be, and you want to submit a project for the 2025 DBIA Project Team Awards, good news, submissions are open now. And this year, the process is streamlined and so much easier. You can find all the details at projects.dbia.org. And if you haven't already, be sure to check out the full November episode for more on the design build elements that help these projects take home DBIA's equivalent of Olympic medals. Thanks for listening to this Design Build Delivers podcast bonus episode. A big thank you to our guests for their entertaining storytelling, Fred Yee for his editing skills, and of course US CAD and Archons Company for making the Design Build Delivers podcast possible. Learn more at uscad.com/DBIA.